Hello, my name is Greg. I'm a CTO at Cobiro, and I've been developing front-end application for the last over the 12 years right now. And today I wanted to share with you some of our experience with building those applications at scale. And like the title of this talk, this session is Life After State. The idea is that we've hit the wall several times with using the state management, and we wanted to show you our journey through those problems and what kind of solutions did we find out. Okay, so some of you might know, but I used to be an architect before being a CTO, and I take the architecture very seriously. So I've been developing not only front end, also some back end technologies. So for me, I've learned a lot of stuff that was very helpful. And one of those very basic concepts, but yet very powerful, is the layered architecture. So I think it's very important to have a structure in your code. And by implementing layered architecture, you can actually write a better code. And it's really surprising how many people use it on the front end. Like, not many people do that. A lot of stuff we deal with like bloated components that do all the logic in there. I think it's a huge antipart, and it's really a mess and difficult to maintain. So let's start with the basic, which is the layered architecture. So in the layered architecture, you would have a layer that represents different concerns. So you would have a UI layer, for example, and the UI layer will be all your kind of components that deal with presentational logic only. So it's very important to keep it only for the presentational stuff. And then eventually you might need to fetch the data from the backend or fetch it from like outside world. So think about it like there is this infrastructure layer which would treat your application. So it would be on the very border of your box of your application. So anything that needs to be communicated in and out from with your application would come through the infrastructure layer. Then eventually you might want to add things like security concerns, or maybe you want to do authentication, authorization, or maybe you want to control the flow of the program. Then you want to have an application layer. So you want to decouple that from the components, because maybe you want to have something that is aware of your whole application, not only about the specific module or specific component. So this is when you actually start adding the application layer things. It could be routing as well. So think about it like this. And then you might need to do some domain logic. What is the domain? Well, think about what you're building. Is it banking application? Is it accounting application? Is it website builder? Or what is it? So when I go into the folder that represents the domain application, I would like to see all the domain concerns. So all your models, all your classes, interfaces that represent that domain. So if you're building an accounting application, if I go there, it needs to scream at me things like VAT numbers or invoice or whatever is it that you're actually building, or maybe overdue payments or whatever. And then when you build like banking, obviously I would like to see some account numbers and things like this. So the reason why you want, because a lot of people put it to the UI layer, and I don't think it's right. I think you should take it out. It's because it's easier to test, it's easier to maintain. And think about it, like if you, let's say, want to move your UI around, now you can do it because the domain and the business rules of your business are not touched through moving the UI. You don't need to drag it along and copy paste the code, or you don't repeat yourself pretty much. And it's much easier to test the business rules if it's in a separate folder. Okay, so when you start a project at Cobiro, it's usually a greenfield project, and then everything is awesome, right? You know the layered architecture by now, and you know what to do. So everything is easy. And then you start with let's say you start with presentational components, then you add some container components on top of it. So these are slightly different concerns. So think about presentational component like something like a lists or items or buttons or accordions. It could be as simple as HTML5 elements, but this is like presentational only. And then you have a container component which would, for example, do something with the input from the DOM event listeners or whatever. So think about it like this is two different things. Container components contain presentational components, and also sometimes they are called smart components, but they are slightly more smart. They are not just a dumb components. And then you want to fetch something from the backend, or you want to save something to the local storage, then you need to create classes representing infrastructure layer. So you would have all your HTTP calls in service, or maybe GraphQL calls, or WebSockets, whatever is it, but you would put it to a separate class. That way you can reuse it with other components, and you can also test it separately, and it's pretty cool, actually. I hope you don't do it in your container component. Okay, the next thing is state. So let's say so the previous architecture was really good for things like CRUD-based applications. So let's say, every page equals separate calls to the backend, and then when it's called, then I want to show it to the user. And, but sometimes life is not as easy like this. This was really cool in 1990s, but now it's different. So let's say what you want to do is also create some state logic. So it could be some counters, it could be some total numbers, it could be whatever, really. It could be the fact that you don't want to call the backend every single time you click a button. Maybe you want to do it in the state and then just output it. I mean, it's pretty basic concept, so I'm sure you understand it. But for me, it was difficult to understand it from architectural perspective. So for me, like when I look at the implementations of some various developers from different companies, then I was always thinking, what is a state? And state is a hard problem in computing, by the way. So think about it, like what is a state? So all we know is I have this nice little layer application service called store. And then the store has a dispatch and select methods, and then I would just do things with my state. But think about it. What is it? Is it application concern, or is it a domain concern? Or maybe infrastructure concern, because you actually persist something. So I think it's all free, or it can be all free if you're not careful. So that was our problem. So when we started to build and build and build, we realized that with the state, we had a couple of problems, and just because we were not careful. So we said, oops, we have some issues, and some of these were like God class. So the state class was becoming very big. It could have hundreds or maybe 1,000 lines of code, and I knew there is something wrong with it, right? And then there was a big ball of math, and things were interconnected. We had some spaghetti code examples and stuff like this, and it was really difficult. And then we realized it kind of breaks. I mean, it definitely breaks the layered model. And then it also breaks some solid principles. So we're not very happy about that at all. So we just sat down and decided, okay, let's just separate the concerns here. So we went and started to use domain-driven design. This is not a lesson about domain-driven design. I'm just going to include the very basic tactical concept of domain-driven design, but trust me, it's a big topic on its own. But generally, think about it this way. We said, okay, we have the state class. Let's just limit that. Let's limit that to the minimum. So what we're going to do, we're going to push it only to the application layer. So application layer knows when something needs to get executed. So we say whenever action comes in from the store, we just execute that function, and that's it. And all the rest, we want to have in a separate thing. So if we want to access services, it's a separate thing. If we want to access the domain models, it's a separate thing. And let's contain all our state-altering logic inside the domain objects. So this is why we've added aggregate and entities and value objects. I don't want to go in detail of it. Like the most important thing is the aggregate, which really defines the boundary of your context, or of the sub-context really of the whole module. And then the aggregate will make sure that things are consistent within itself. It has invariance and covariance. And then what would happen is aggregate would represent a state of a specific entity or a specific thing, you can say, and then output that to the state, and state would persist it in this, it will persist it. And that way, we can actually remove the state manipulating logic into its own classes, which was pretty cool. But we realized we still have some issues. It's not as easy as that. So what happens is we started to dig under the hood of specific libraries that we were using. And I'm pretty sure you guys think that your own doesn't have those issues and something I don't know. But trust me, they are very similar under the hood. But okay, the ones we used, I can only say that we had the problem with centralized global state. Like when you look at it, of course you might have reducers or whatever thing you're actually using, but actually you just take the piece of the same centralized state. And that was sort of a problem for us. We also realized that communication between the states is not very easy. Like you have to communicate, and those communications are tightly coupled quite a lot of time, because think about it, how do you actually do it? Like, do you have like a upper state and then lower states? Well, that's also sort of form of a coupling. Do you dispatch an action from some state handler to another state through store? Well, that's spaghetti code, right? And then there were a lot of issues with that. Maybe you should select a part of the state from within the state handler function. But then you realize, well, yeah, but I'm going outside of my binary, right? So I'm start to couple other state. If they change something in that module, I'm gonna have a problem here. So we had the problem with efferent coupling. So we realized that some classes were so important that changing anything there would have a negative effects on the other modules. So we said, that's a problem. And then we sat down and say, okay, but these problems maybe are not necessarily the state problems. They are the problems around architecture. So we said, okay, let's modularize our architecture even better. Let's just make some rules that will make our architecture better. And it's all handled, been done before in microservices on the back end, and it's also like being done on micro frontends on the front end. But the idea is very simple. Let's have an application layer, but like a global application, which will contain all the routing, security, feature toggles, and all the stuff we want to have. And then let's have modules. And each module, there is a rule. Modules must not know about other modules. Okay, that's good. Then application can know about the modules, that's fine, but the module should not know about the application. And each module can be actually managed by a separate team of people. But then we get to the point of how do we communicate? Well, we communicate with application service called application event bus. And then this application event bus will issue events, and then each module would subscribe to this application event bus and to specific events from other modules. Yes, we couple the events, but coupling events is much better than coupling the whole modules. So we can achieve high cohesion and low coupling, loosely coupling. So it's pretty cool, actually. Okay, but then we realized, fine, but even with that approach, we might have some other problems. And other problems include some modules, even though there are well-defined contexts and they have its own aggregates with well-defined boundaries, they are just big. They're just big, and you can go around it. Like some of these will, the state classes of those, because we were still using states inside those modules, will become very big. And, like let's say you have a 50 action handlers, right? And then each 50 has at least 3 or 4 lines of code. Well, you add up to more than 100, 200 lines of code. It could easily be like that. And that was a little bit too much. And, browsing those files and this temptation of calling one, or like in this action, call another action was very tempting. So we had still the same issues with actually centralizing that state. And then we also have, we wanted to have something more lightweight. It's because now when you start scaling horizontally with a lot of modules and each one of them has state, or some of them have state, then, keeping the version between them might be a problem. You have to restrain, maybe some team wants to use their own state management system, and we don't kind of like that because we like to keep the stack simple. So it was very heavy, and yeah, sure, you can lazy load the modules, but let's say the user goes through all the website eventually, so lazy loads all of them anyway. So we wanted something more lightweight. And then we also said, when I started building my domain, and some of it is really big, my domain models are not really something I push to my views. So I would like to decouple, so it's sort of like an analogy of the selector. So I would like to decouple the read and write models that they should be totally different and loosely coupled from each other. They should not know about each other. And then also the read and write storages. Like in some cases, I would like to use different storage for reads, different storage for writes. And what do I do about this? So we went with the command query responsibility segregation, CQRS for short, and we decided, yeah, let's just get inspired by this and create some architecture that we can use. So here we go. So imagine this is a module. So this is, you can see the UI on top, but it actually represents a multiple component that can be used. So there are a couple of rules here. First of all, a single command can use a single command handler, and then query will represent a query for a single UI container component. So we want to have these two separate. A container component now has, we wanted to have two dependencies, up to two dependencies, because having one dispatch and select felt a little bit like separation of concerns that we could avoid. So we say, okay, let's have two dependencies. One will be for the command bus, so the dispatch thing, and one will be for the query stream for fetching the data into the container component. And it's slightly different because we also use RxJS for it. So the idea is that command bus is just a very simple, you just find the command handler and dispatch the command on it. And then the query stream is a little bit different because we want to have this reactive feel to our application. So actually, instead of like polling it once in a while, we just actually subscribe to it, and whenever it changes, we just push the data to the component. So it's pretty powerful. Okay, and then if you want to communicate between the command and the query part, these are two separate parts. Remember, they don't know about each other. We need to decouple it through event bus, just the same way as we had application event bus before. So when we decouple these two, now we can have two handlers, one for the command, one for the event. And yeah, they are coupled through event, but it's much better. And then command bus will dispatch and find the command handler, which is only one per one command. So now it's much easier to find it, much easier to actually compare it with the other handlers as well. And then the event handler will actually listen to those events and then do something with the query. Now, we can have two different models, one for the domain, one for the query. Query is like optimized for the view. It's exactly make it fix easier for the view to actually render it. And the domain is a lot more like rich in logic. And then we can have two different storages. So I can have one storage for the command, let's say it's a service that connects with the backend, and one for the query, which could be just in-memory storage, which doesn't do anything. If I want to persist it across different loadings of the website, like refresh and stuff, yeah, just use local storage, IndexedDB, whatever you want. But for the command, very often use case is just, it's a backend service. You can also vary it slightly. So now I have two decoupled things. So one is the command part, another is the query part. I know in the normal CQRS you would actually sync it on the storage level, but here we have a couple of nice benefits with using this on the application level. I can talk about it some other time. But generally, this is the proposed architecture. It works very well for us, and it makes code a lot clearer. So now a single command can have effect on multiple components and multiple event handlers, and it's actually very cool and very neat. And some components don't need to have a command part. Maybe they just have a query part, and that's fine. Okay. So a little bit of announcement here as well is that we would like to open source it eventually. So for now, we're still building it and still like do some tests and production, so we can have 100% sure everything works. And once we do, we want to keep it like platform agnostic. So all you need is to have a support for RxJS and then use it then. So you can use it in a React, in Vue, in Angular, whatever you like, So hopefully it's going to be very nice for the rest of you guys. And then with that said, I want to thank you for listening to my presentation. I hope it was useful, insightful for you, and I hope you learned something. If you ever want to get in touch with me, you can find me on Twitter with Greg Radzio, and then on Medium as well with Greg Radzio as well. So it's pretty much the same. So with that being said, thank you all for coming, and I wish you a very nice day.